Hello students, welcome back. I am Rinkesh sir and today we will start with exercise 2.2. In our last video lecture we had completed with exercise 2.1. Now before starting the exercise, let us see which topics will be covered in today's video. Today we will study about relations, domain, codomain and range. And based on these concepts, we will start exercise or we will solve exercise 2.2. Clear? So let's start with the topic. Now, relations. Now, what are relations? Now, see, let's take two set P. Okay, let's take the alphabet of P are A, B, and C. Okay, and let's take Q that is equal to 1, 2, 3. Right? So, P cross Q. There will be equal to how many elements? That is 3 cross 3, that will be equal to 9, right? So that will be equal to A1 B, sorry, A2 A3 B1 B2 B3 C1 C2 C3, right? I can also represent this P cross Q in the form of arrow diagram like this. Let's name this as P and this as Q. So the number of elements or the elements in P are A, B, C and in Q are 1, 2 and 3. So from A the relation can be A1, A2, A3. From B, B1, B2, B3. And from C, C1, C2 and C3. So this is in the arrow diagram form. Okay, this is called arrow diagram. Okay, now we can form any subset of P cross Q as a relation. Means if I give any relation R equal to X, Y such that X is Yth alphabet, right? Then see, when I take Y equal to 1, then which is the first alphabet? A. So A1. When I take Y equal to 2, then which is the second alphabet? B. When I take Y equal to 3, which is the third alphabet? C. Or else when I take X equal to A, right? When I take X equal to A is which alphabet? It is the first alphabet. Okay, when I take B, which is the alphabet B, B is the second alphabet and C is the third alphabet. So here you can see that R is subset of P cross Q, right? So relation from P to Q, I can write it in this way. R, it is from P to Q. The relation is from P to Q, then this relation will be subset of P cross Q, right? Where P is called the domain. Okay, Q is called the codomain. Okay, in this case, 1 is the image of A, 2 is image of B, and 3 is image of C. So this image is the set of all these images, they are called range. So here the range will be equal to 1, 2, and 3. Remember, the range is always the subset of codomain. Okay, so don't get confused with the term range and codomain. Range and codomain are different. Codomain here is this complete set Q, right? And range is the image of the elements of the P. Okay, let's take one more example. Let's take one more example. If I take a set A, let's say set A that is equal to 1 4, and set B equal to -1 +1 2 3 4. Now if I define the relation R equal to x y such that y is equal to square root of x, x belongs to A, y belongs to B. Okay, if I don't want to write down this x belongs to A, y belongs to B, then the other thing is relation is from A to B. So that means the element x element belongs to the domain that is A. Here A is the domain. The element y that belongs to the codomain that is B. Clear? So now when I will solve it, right? When I solve it here, then if I take x1, x equal to 1, then y equal to +1 -1. When I take x equal to 2, y equal to +2 -2. But in my codomain, I am not having -2, right? So what will be the relation? The relation will be equal to x1 y1, x1 y -1, x2, sorry, x4, sorry, my mistake. When I take here x as 4, at that time y will be equal to +2 or -2, but -2 we are not having. So x4 y2. This will be the relation. So what will be the domain? Domain is equal to A, that will be equal to 1 4. What will be the codomain? Codomain will be equal to B, and that will be equal to -1 1 2 3 4. And what will be equal to the range? Range will be equal to 1 -1 and 2. See here, the image of 1 is 1, 1 is -1, and for image for 4 is 2. So this is the range. So I hope you will easily able to differentiate codomain and range. Clear? So now let's move to exercise 2.2. Question number 1. Here set A is given as A equal to 1, 2, 3 up to 14, right? B, and here the relation is from A to A. And what is the relation given? Xy such that 3x minus y is equal to 0. See, 3x minus y equal to 0. That implies y is equal to 3x. So see, let's take the value of x. Which value I can take? From A, from domain A. Remember, the first element will be from domain and second from the codomain. So here value of x can be 1, 2, 3, 4, 5 up to 14, right? And value of y, what is y? 3x. So 3 into 1, 3, 3 2s are 6, 3 3s are 9, 4 3s are 12, 5 3s are 15. But say 15, this is codomain A. Are we having 15 in A? No, so I cannot take this value. I will move forward, it will be greater than that. Clear? So see what will be the relation here. R will be equal to its ordered pair xy. So when x is 1, y is 3. X is 2, y is 6. X is 3, y 9. X is 4, y 12. So this is the relation. Clear? So now domain will be equal to A, that is 1 2 3 4 up to 14. Codomain, that is also equal to A. But range here will be equal to 3, 6, 9, 12. Okay, what is the range? So this one 3, 6, 9, 12. Clear? If I need to list it down, then this will be same 1, 2, 3, 4 up to 14. Similarly here also, because this is the codomain. So 1, 2, 3, 4 up to 14. But in range, we only need to take these elements 3, 6, 9, and 12. Okay. So solve question number 1. Okay. Now let's move to the next. That is question number 2. Question number 2 is define a relation R on the set N of a natural number by R equal to xy such that y equal to x plus phi. Now see, here relation on the set N, that means R is from N to N, but we need to check what is x, right? So xy such that y equal to x plus phi, and x is a natural number less than 4. So here it is given y equal to x plus phi. Now what values I can take of x? Okay, here it is given x less than 5 and x is a x less than 4, right? And x is a natural number. So the value of x will be 1, 2, and 3. Clear? So what will be the value of y? So 1 plus 5, 6. 2 plus 5, 7. 3 plus 5, 8. Okay? So the answer relation will be equal to 1, 6, 2, 7, 3, 8. Clear? So now what will be the domain? Clear? See here in domain it is given x is a natural number less than 4 and xy belongs to n. So domain will be equal to which value of x we can take 1, 2 and 3. Okay, and what is the range? Okay, this is the range 6, 7 and 8. Here, so note down question number 2. Now let's move to the next one. That is question number 3. Question number 3. Here set A and B are given. Okay. Set A it is 1, 2, 3, 5. And set B it is 4, 6 and 9. Now define the relation R from A to B R x y such that the difference between x and y is odd, right? The relation R is from A to B. Now it is such that X minus Y is odd. Clear? So let's take the values X. Which values I can take of X? 1, 2, 3, 5. Okay, and which values I can take of Y? Clear? So now it's 1. We know that the difference of two odd number will be always even. So here Y will be only even. So I have three options: 4, 6 and 9. From that, which are even? 4 and 6. Now here it is 2. So if I want the difference as odd, the another number must be odd. So from 4, 6 and 9, 9. Similarly 3 is odd, so 4 and 6. 5 is odd, so 4 and 6. Okay. So what relation I got? When I take 1, I can have two values: 1, 4, 1, 6. When I take 2, the relation is only with 9. When I take 3, the relation is between 4 with 4 and 6. When I take 5, 4, 5, 6. Okay, so this is the relation R in Rooster form such that the difference between X and Y is odd. Clear? So note down question number 3. Okay, now let's move to question number 4. Question number 4. So the figure shows a relationship between the sets P and Q. Write this relation first in set builder form and second in uh, rooster form, and you have to write down what is its domain and range. So first let's solve the second one. Okay, I will solve here the second one. In rooster form, R will be equal to, when it is 5, it is linked with 3. When it is 6, it is linked with 4. When it is 7, it is linked with 5. Right? So what are the domain? Domain is 5, 6, 7. These are the domain. 5, 6, 7. Range means the image, so 3, 4 and 5. Okay, so 3, 4 and 5. So this is the rooster form, domain, range. Now the first one, in property method. So the relation R is from P to Q, right? So R is equal to xy such that, now see here you will see 5 minus 3 2, 6 minus 4 2, 7 minus 5 2. So I can write it down such that x minus y is equal to 2. X belongs to P and y belongs to Q. Clear? So this is in the set builder form. Here, so note down question number 4. Now let's move to the next question, that is question number 5. Question number 5. A, set A is given here. Set A, it's 1, 2, 3, 4 and 6. And the relation is such that AB such that B is exactly divisible by A. In short, B is a multiple of A, right? So I take two values here, A and B. What values I can take? A 1, 2, 3, 4, 6. B. Now this we have to take the number here such that it is divisible by 1, or it is in short a multiple of 1. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There can be any number, but here I can take only till 6 because the relation is on A. That means I can say that R is from A to A. So codomain is A. So I will write it down 1, 2, 3, 4, 6. So 2 number divisible by 2 or multiple of 2, 2, 4, 6. We are not having 8, so we will be only 3. Number multiples of 3 or divisible by 3, 3, 6. For 4, it will be 4, next is 8, but we are not having. And for 6, it will be only 6, right? So what will be the relation in rooster form? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Sorry, we are not having 5. 1, 6. Clear? Now from 2, 2, 2, 2, 4, 2, 6. 3, 3, 3, 6. 4, 4, and 6, 6. So this is the relation. Yeah. Now the second question here is you have to write down the domain. So domain will be equal to which values of A I have taken? 1, 2, 3, 4, 6. That is A. Right? So 1, 2, 3, 4, 6. And that is equal to A. Right? Because this is the domain. Clear? And the third, you also have to find out the range. So range means all the elements this which we have taken here. 1, 2, 3, 4, 6. Here 2, 4, 6, 3, 6, 4, 6. So 1, 2, 3, 4, 6. Now this also supposed to be A. Clear? So this was about question number 5. So note down question number 5. Okay students, so that's it for today. In our next video lecture, we will continue with exercise 2.2 from question number 6 and we will complete exercise 2.2. Thank you.